Hey, this is Logan Knight, and I'll be presenting my Physics 2212 Lab 1. So for this first lab, we're told to find the excess charge on one piece of charged tape by observing interactions with neutrally charged objects as well as other charged pieces of tape and objects. And to do so, we were able to use mathematical equations, physics principles, and a computational model. So our first step in this was to find our length of the tape to be 0.2 meters and our mass of the tape to be 0.002 kilograms. And our principles used in this were electric field, Coulomb's law, as well as Newton's laws. So for interactions of U-tapes and conclusions, so for my expectations, I thought when two U-tapes were brought close together, they would move away from each other, since I expected they have the same charge since they're charged in the same way. And for our interaction between U-tapes, we found that they did repel one another. And our interaction between neutral objects, the tape moved towards neutral objects. As I held it towards close to my desk, it moved towards it with that attraction. And for interaction of positively charged U-tape and negatively charged plastic pin, they would attract to one another, and for negative and negative, they would repel one another. For our interaction of neutral U-tape and charged plastic pin, the neutral U-tape would attract to the charged plastic pin. And for our interaction between the charged U-tape and charged plastic pin, the U-tape and charged plastic pin would repel each other. And I got for my charge of the U-tape to be positively charged since it did attract to a negatively charged plastic pin. So for our calculations, so during this part of the lab is when we had our two U-tapes, one above the other, and we brought that bottom one up until the top one began to float, and we found that distance to be 0.04 meters. And from this distance, we're able to calculate our magnitude of gravitational force as well as our magnitude of electric force to both be negative 1.962 times 10 to the negative 3 newtons. And from this, we're able to get our force of tape A on tape B to be 1.87 times 10 to the negative 8 coulombs. And then we're able to calculate from our force of A on B divided by our force of an electron. We were able to get the number of electrons to be 1.17 times 10 to the 11th electrons. And our number of atoms from our length of the tape divided by our length scale of an atom, we got 2 times 10 to the 9th atoms. And from these two calculations, we're able to get our ratio of atoms to electrons to be 58.5 atoms to 1 electron. And from these calculations, we're then able to transfer it into a glow script code or computational model in order to get that electric force of the charged tape to be, as well as to see our free body diagram. So from our code, we're able to see that the electric force on a charged piece of tape is 1.96 times 10 to the negative 3 newtons. And we're also able to get this free body diagram with our red sphere being our top piece of tape and our blue sphere being our bottom piece of tape. And our purple arrow being that electric force coming from that blue piece of tape as it pushes up onto the red, causing it to float. And our yellow arrow is going to be our gravitational force pointing downward. So for our glow stick data, we're able to get the magnitude of the charge to be 1.8667 times 10 to the negative 8 coulombs. And for our assumptions, we have to say that we're going to ignore our air resistance on a moving object. We're also going to treat the long tape as a point charge in order to rearrange our equations and calculate the charge correctly. So for what if and what does it mean? What if electrons were now positively charged and protons were now negatively charged? I would expect that our observations would instead be the opposite of we originally saw. So if a U-tape did attract to a neutrally charged or charged object, I would think it would instead repel, and vice versa, since again, those electrons and proton charges have changed. And then it's very important to handle the charged tape as little as possible. And this is because when the tape comes in contact with your hand does remove some of the charge from that tape and makes it have a neutral charge instead of being charged. And then since this charged tape would not be, this charged tape would not be as charged as it could have been, especially for our floating tape equation, it might give us a different distance they need to be apart before that tape begins to float, since it has less charge than it would have originally. So for critiques and conclusions, my critiques were that I should have handled the tape less. I had some trouble in the beginning with it sticking to me, and I had to recharge it a few times, but towards the end it did get easier. I also found that the floating tape portion of the lab was a bit difficult to do measurements without error. For me, it was very hard to get an accurate distance between the top and the bottom when the top tape began to float. And for my conclusion from this lab, I was able to see the different effects that a charged piece of tape has on charged objects and neutral objects. And I think this lab really helped with my understanding of electric forces on the atomic level, as well as how to better relate equations and relate the different components of forces on that atomic level.